Assalamu alaikum. In this video, we will make the opposite conversions, which are from decimal to any other radix. And here we will make the conversions from decimal to binary, to octal, and to hexadecimal. All these conversions are made using the same method, which is the following. So the method has two steps. The first one is to convert the integral part by repeatedly dividing the number by the new radix and saving the remainders. Okay, and then we will read the remainders in reverse order. In the second step, we will convert the fractional part by repeatedly multiplying the fraction by the new radix and saving the integer digits that result in the multiplication. Okay, so we will take these examples here. So here, for example, we need to convert 46 to base 2. Okay, so 46 is in base 10. Now, when we do not specify the base, this means that it is in base 10. So we need to make, so here we only have an integer part. We do not have a fractional part. So we will write the result here. 46 in base 10 is equal to this result in base 2. Okay, so the method is to start by converting the integer part. We do not have fractional part. So 46 divided by 2 is 23, and the remainder is 0. Okay, then we continue until we arrive at 1 or 0. So here 23 divided by 2 is 10 and 1 is 11, and the remainder is 1. Now this is 5, the remainder is 1. Divided by 2, this is 2, remainder is 1. 2 divided by 2, this is 1, and the remainder is 0. So here we have to stop because we found an integer that is smaller than the radix, which is 2. And now we need to write the result in reverse order from 1 until 0. So the result will be 1, 0, 1, 1, 1, 0. 1, 0, 1, 1, 1, 0. This is the result. Of course, if you want to verify the result, we need to make the opposite conversion. We will do it here. If you want to convert this to decimal, this is 2 to the power of 0, 2 to the power of 1. So I'll write directly the result of the power. So here this is 2 to the power of 2, which is 4. This has the weight of 8, this 16, and this has the weight of 32. So the result is 32 plus 8 plus 4 plus 2. So this is 46. Okay, so the result is okay. Now, if we had a fractional part like here, what we should do is to make successive multiplications. So 6, 8, 7, 5, we multiply it by 2. This gives 10, 15, 41, 6 multiplied by 2 is 16 plus 1, 17, 12 plus 1, 13. So this one here, we need to write it directly here. Now we take the result here and we continue multiplying by 2. So this will give us 0, this will give us 10, 7 multiplied by 2 is 14 plus 1, 15, 3 multiplied by 2 is 6 plus 1, 7. And here we have 0 point. So we obtained a 0, so we need to write the 0 here. Now we continue 0.75. We can discard these zeros because they are at the right of the number, so they do not have any value. So multiplied by 2, this is 10. 7 multiplied by 2 is 14 plus 1, 15. 0 multiplied by 2, 0 plus 1, 1. So we take this one, we write it here, and we are left with 0.5. So 0.5 multiplied by 2 is 1. So which means it's 1.0. So we just need to write 1 here, and we stop because we are left with um, nothing after the dot here. So this is the result of the conversion in base 2. Okay. So now, if we had here 46.6875, the result will be joining the integer part with the fractional part, which will give us this. So this is the result that we found here, and this is the result that we found here. Okay, so now we have an issue, and we'll see an example of this issue. And this issue is about the fractional part. So when we multiply the fractional part, we do not always come to a point where we have a 0 after the dot. So in this case, we need to truncate the result and choose the number of bits at the right of the radix point where we need to make the truncation. So let's look at this example here, 0.65. So I'll make it here. So imagine we have 0.65 in decimal, and we want to convert it to binary. So we'll make the successive multiplications. So 0.65 multiplied by 2 is 10, 13. So 1.30. So we need to write the one that we got here, and we make the next multiplication. So this will be 0.6. We get 0. We write it here. Now we have the 6 multiplied by 2, 0.6. So 0.6 is 1.2. We have a 1. We write it here. Now we have 0.2 multiplied by 2 is 0.4. We get a 0. We write it here. Now 0.4 multiplied by 2 is 0.8. We write the 0 here, this one. Then we make the multiplication again. Now we have 1.6. So we take the 1, and then we write it here. Now what we have 0.6 multiplied by 2, and we can see that this is exactly the same operation that is here. So we can imagine that we will repeat all these steps starting from this point. So we'll get 1, 0, 0, 1 again. So this result will repeat here indefinitely. So if we do not stop, we will never get to a point where we get a 0 at the right of the radix point, because this is the stop condition that will stop this algorithm of multiplication. So here in these situations, we need to specify the number of points. Okay, so sorry, I forgot to put the 0 here. So this is 0 pointer. So here we need to specify the number of digits that we need after the radix point, at the right of the radix point. So this is the precision of the number in binary. So if we choose, for example, precision of 8 digits at the fractional part, we will truncate the number after the 8 digits. So we'll take these 4 and these 4. So here we will truncate the result that comes after. So we'll write that 0.65 in 10 is approximately 1010011. Okay, there's still a 0. We do not need to write it, but it's there. So this is the approximation using 8 digits. If we need more precision, we need to add the digits at the fractional part. So maybe 8 digits is not precise enough for our application, so we need to add the digits that represent the fractional part. Okay, so this depends on the application, but it's not our subject here. Now we only looking at these cases. So when we have these cases, we just need to specify the number of digits, after which we will truncate the result. Okay, so this is how we do the conversion. Okay, so let's take this example. For example, we have here 0.8542, and we need to convert it to binary. So we'll make, because we only have a fractional part, we will make successive conversions, multiplications. So this will give us 4, 8, 10, 16 plus 1, 17. Sorry for that. So I'll write the result here. So we need to write 0 dot, and then we report the first one here. Then we continue the multiplication. We have 8, 16, 1, 14. So we are left with 0. So 0 multiplied by 2 is 0, plus 1. This is 1 point. So we take this one and we report it here, and we continue. Okay. Now we have 16. 6 multiplied by 2 is 12, plus 1, 13. Here we have 3, 12. Sorry, 8. So here we have to report the 0 that is here, and we continue. 12, 7, 6, 16. We report the 1 here, and the question says that we need to give the answer to the 6 digits after the fraction. So now we already have 4. We continue. 4, 14, 12 plus 1, 13, 13. So we have 1 we reported here, and then we continue the multiplication. 0.3344 multiplied by 2. This is 8, 8, 6, 6, and we have to report the 0. Okay, so now we got our number. Of course, this is not exactly an equality. The number is an approximation of this number, but the binary system is like this. It's not, if we have a limit in the number of digits, the number will not be completely, not always be completely the exact number in decimal. So it's only an approximation. Now, if we are doing the conversion to decimal, or from decimal to octal, we have 175.5 in decimal. We want to convert it to octal. We will start by, so we will have 2 steps here. We will have a first step where we will make the successive divisions, and a second step we will have successive multiplications. So we take the integer part, we divide it by 2. This will give us 175 by 2 is 80, 85, 87. So this is 87, and the remainder is 1. Divided by 2 is 43. The remainder is 1. I'm sorry, we need to make the conversion to octal, so we need to divide by 8. So here we will have 175 divided by 8 is 160 plus 8, 168, 172. Okay, so it's 22. So 22 multiplied by 8, 16 plus 117. 2 multiplied by 8, okay, so it's 21. Okay, so 1 multiplied by 8 is 8. 2 multiplied by 8 is 16. 178. 168. So 21, and the remainder is 7. Now we divide by 8 again. 21, it's 2, and the remainder is 16. 4 plus 1, 5. And then we just need to read the result from bottom to from in the reverse order. So this will give us 257 point, and then we continue here by doing the conversion of the fractional part. So 0.5 multiplied by 8 is 4.0. So we have a 4. We just reported here. And here we made the conversion to octal. Now let's do the hexadecimal conversion. So it's always the same method. We want to convert from decimal to hexadecimal. We need to make, here we only have an integer part. We need to make successive divisions by 16. So 16 multiplied by 20 is 320. Huh? So we are left. So we have 20 here, and we are left with 13. Okay, so 13 we need to encode it using the hexadecimal system. So 13 is A is 10, A is 10, B is 11, C is 12, and D is 13. So this is a D. And we continue the division. So here we have 1, and we are left with 4. So the result is 1 for D. So 333 in decimal is 1 for D in hexadecimal. And if we had a fractional part, we would need to make successive multiplications like we did with the other bases.